This video is about the building blocks of atoms. All the devices you are using, they are based on this idea that within atoms we have charges, positive and negative charges, and we exploit these charges in a way that we can make them move to a position where we want them to transport energy. And in order to understand this concept, which we will cover in upcoming videos, we need to understand how atoms are built, what atoms are, and also how Bohr's atomic model works. And the knowledge from this module here lays the foundation to understand the concept of electric charge, which we will cover in great depth in upcoming videos. My name is Andreas from the Fearless Engineer, and here we go. Eventually, over the course of this lecture, we want to understand what electricity is, and we also want to understand how energy can be transported into an electric circuit to power a certain device. And in order to understand that, we need to take a very close look at the core of things, at the nucleus of matter, and this is the atoms that make up everything around us. And atoms, they exist in over 100 different forms as chemical elements, which are listed in the table of elements. And you have surely heard about hydrogen or carbon or oxygen or copper or even plutonium or uranium. And what you can see here, this small copper coin here, assuming it were to exist out of 100% copper, we can compute the number of atoms it contains, the number of copper atoms, and arrive at approximately 2 × 10 to the power of 22 copper atoms within this small coin here, just to give you an idea of the numbers we are talking about. And from the set of properties which describe an element, which might be something like size or weight, we are very much interested in the electrical conductivity here in electronics, because this is the vehicle which we will use to conduct electricity, to convey energy into a system. And to explain the mechanisms behind conductivity, in order to understand this properly, we first have to take a look at the basic building blocks of atoms, which are electrons and neutrons and protons. Now, this here is not a physics lesson. We will not discuss quarks. We will not discuss quantum theory here. We need a very simple mental image of how atoms are structured in order to move forward to get to the electronics section of this lecture. And in order to do so, we will limit ourselves to the major particles which make up an atom. Atoms are built out of a combination of 3 different particles, which are electrons and protons and also neutrons. You can see them in this little diagram here. You have the nucleus in the core. The nucleus is made up out of protons and neutrons, and they are densely packed in this nucleus here. And the neutrons, they bind the protons to the core, to the nucleus. So protons and neutrons on the inside make up the nucleus. And every atom has at least 1 proton and also an identical number of electrons. The electrons, they circle around the nucleus in various orbits. An orbit means basically a circular path around the nucleus with a varying distance. There are several orbits depending on the atom. You might have only 1 orbit, you might have 8 orbits or even more, but the electrons, they encircle the core on these orbits. And if you count the number of protons of an uncharged electrically neutral element, you will automatically be able to deduce the number of electrons. The number of protons is identical to the number of electrons. And this very simple idea of a center core, which contains protons and neutrons and electrons encircling, surrounding this core on various orbits, was first postulated by Niels Bohr, a very famous physicist from Sweden. And in 1913, he publicized the Bohr atomic model. And in this model, which you can see here on the right-hand side, he arranged the core in the center. And the number 29 here gives you the number of protons in the core, and the electrons are arranged in these discrete orbits here. And protons and electrons, and this is a very fundamental concept which we will exploit in electronics, is that they exert an electrostatic force on each other which is proportional to their relative distance. There are many forces at play here between particles and between the core and between the surrounding electron cloud. But what we want to focus on is the electrostatic force, because this is the one which we will be able to exploit to a great deal. And this electrostatic force between protons in the nucleus and the electrons in the orbits decreases when you move outward from the core. So the force is strongest between the electrons closest to the core, and it's weakest between the electrons on the outermost orbit and the core. And the ability of particles to exert this electrostatic force is defined by the concept of electric charge. So the major takeaways from this video are that you need to understand that atoms consist of three major particle types, two of which are important to electronics, protons and neutrons. Between these particles there exists an electrostatic force. They repel each other or they attract each other, and this force will be described in one of the next videos by the concept of charge, electric charge, and we will express this force by using a very famous formula which you might have heard about, which is called Coulomb's formula. But before we get there, before we discuss the Coulomb force in great detail, let's first do a few exercises regarding the number of atoms in a certain material, which is the topic of the next two videos. Let's quickly summarize the main points from this video. You have learned that atoms consist of basically three particle types, which are protons and neutrons and electrons. And the first two, they form the atomic core, which is in the center of the atom. And the electrons, they exist on orbits around this center core. And depending on the position on which orbit the electron is, there are forces at play which interact between core and electron. And we do not want to dive too deep into physics here. The only force we are interested in here in this electronics video is the electrostatic force, which can either be repulsive or attractive depending on which particle types you mix. For example, if you take two electrons or two protons, they will repel each other. If you interchange the particle types, electron and proton, or vice versa, they start to attract each other. And this force is best thought about by using the concept of charge, electric charge, which is the topic for the next video to come. So for now, you know how atoms are built, how the particles interact within an atom, at least on a very superficial level, and you have this image in your mind of the Bohr atomic model, which will come in handy when we talk about compounds of atoms which form, for example, a copper conductor. And we can also better explain in this upcoming video how it can be that the outermost electron frees itself once the atoms in such a compound arrange themselves in a certain way. For now, that's all. I hope you enjoyed the video. If you have any questions, please do not hesitate to drop me a question down below in the comments. I wish you a nice day. See you next time here on The Fearless Engineer.